This is Lab 1, Charge Tape, Physics 2212 by Camille Branch. Here is a table of contents for this experiment. Introduction. The purpose of this lab is to observe the interactions between two charged pieces of clear tape. We will then calculate the charge transferred from one piece of tape to another and configure its computational model using GoScript. In some fundamentals before we start, Newton's second law tells us that the acceleration of an object is dependent on its mass and the net force applied to it. Coulomb's law tells us that the electric force of two-point charges is dependent on their charges and the separation distance d, and K constant of 9 times 10 to the 9th, and then there's the equation right there. And then the charge of an electron is negative 1.6 times 10 to the negative 19th, and then the length of an atom is 1 times 10 to the negative 10th. Okay, so here's the procedure of this experiment. So first you're going to create two U-tapes, labeling one A and the other B, and then you're going to suspend tape B onto two objects so that it has some slack. Bring tape A closer to tape B and observe the way they interact and note its separation distance. Then record the observations and analyze and model the data. Okay, and then here are some observations from this experiment. So for the measurements, we took down the tape's length, its width, and its mass. And when we brought the two tapes together, it had a separation distance of 0.017 meters. And then if the U-tape is positively charged, then it should be attracted to a charged plastic pen, which is negatively charged, otherwise it should repel. And a neutral U-tape repels from a negatively charged pen. Rubbing a clear plastic pen on cloth, then putting it closer to the U-tape makes it repel. Then the net Y component of the force on tape B equals 0. And the main vertical forces in the Y direction that's affecting the tape is the gravitational force, and the electric force exerted by U-tape A. When two U-tapes interact with each other, they will repel because they have the same charge. The two U-tapes repelled each other, and when one U-tape interacted with a neutral object, the tape was attracted to it. Now, with our data, we can create a computational model using GoScript. So just look through this code real quick. We have a couple of our constants. We have the K constant, the charge of an electron, the mass, length, and width of the piece of tape. And then we have the gravitational acceleration, the separation distance, and the length of an atom, and then the number that we're going to scale our computational model by. And so here's how we make that. So for the math, you're going to calculate the force of gravity and the electronic force using the tape's mass times the gravitational acceleration. And then for the electric force, it's going to be the negation of that. And then to calculate the charge on tape B, you're going to reconfigure Coulomb's law to solve for Q, and that is the equation that you get. To calculate the number of electrons, you do the charge on the tape divided by the charge of an electron. And then to get the number of atoms present on the sticky side of the tape, you're going to do the length of the tape times its width, which is the area, divided by the atom's length squared. And then the ratio of those two is just the division. And then to plot that, you're going to create a sphere with those dimensions right there. And then once you run everything, then you should have a computational model like this, where the tape charge has a 7.93 times 10 to the negative 9 coulombs. The tape has an axis of negative 4.96 electrons, and there are about negative 9.9 times 10 to the negative 8 atoms for every electron. And then some errors in this experiment could be that the charges on the pieces of tape were not equal. The pieces of tape are not point charges, and the charges on the tape could have been transferred to another surface. And now for some theoretical questions. What if the tapes had negative charges? Would this change the result of the experiment? And the answer is no. The results of the experiment will be the same. The U-tapes will still repel because they have the same charge, but the literal amounts of the charges may be a little bit different. Thank you.